Okay, if I seem a little distracted for this recording, it's because there's a Raptors game on and it's in double overtime, and I'm trying not to pay attention, but I gotta get this done. All right, so how this part of the note works. This is graphing part 2, and graphing part 1 had us go through a couple of questions from page 20 and a couple of questions from page 28. So we've got this question. We finished it. I'll be coming back to do end behavior with that. Second, then we did this question. I'll be coming back to this to do end behavior with this question. I'll be coming back to this question to do end behavior. I'll be coming back to this question to do end behavior. I'll be coming back to this question to do end behavior. But for right now, we are looking at these 3 questions. So these are, in some shape or form, Wayne Gretzky questions, as in there's tricks to it, there's patterns. So these are not long questions. They can be if you don't notice the tricks. They can be done normally, and I'm air quoting that, meaning you can just gut them out using the f at x long division synthetic division process. But for right now, I'm going to move what I call D, which is nowhere close to D, onto a new page, and I'm going to pull E, which is nowhere close to E, onto a new page. Notice how I don't have any axes for this. I will worry about that later, and I'm sketching using X and Y axes. So, sorry, X and Y intercepts, my bad. So when we do this question, if it's in standard form, which it is, you're forced to put it into factored form. You have to put it into factored form, otherwise you can't even find the X-intercepts. So I'm going to do that, but you're going to be struggling a long time to do the f at x long division synthetic division method with this, when really, if you noticed, and remember that y and f at x are equivalent to each other, if you notice, this is a difference of cubes. So we could easily, and I roll my eyes at that because it's not easy, easily difference of cubes factor this. So I can take the cube root of 64, so 4 times 4 times 4 is 64, the cube root of x cubed, which is x. I can square both of those. I can take the cube root of 27, 3 times 3 times 3. I can square it, and then I can multiply those two together in the center. And then sum or difference of cubes has us look at the original question, keep it, change it, always plus. So I don't know if you remember, but this is not factorable. I have mentioned that before. In fact, it's so not factorable that you end up with i's, which create complex numbers, so this isn't even worth looking at. And if you did the quadratic formula for this, you would not get any answers that are graphable because you would end up with i's. So you don't actually have to gear that out if you don't want to. As long as you say something knowledgeable about this, that's great. While I'm thinking of it, this is a quadratic function as opposed to a quadratic equation or a quadratic expression or a quadratic formula. I'm about to find the X-intercepts, which means I'm taking my quadratic function and I'm turning it into a quadratic equation. Actually, it's not quadratic right now. It's cubic. So I'm taking my cubic function and I'm turning it into a cubic equation. Again, my bad. I should not be looking at the TV. I don't have to worry about this because I am so smart. I can take 4x minus 3 equals 0. I can do my work or not, depending on how careful you want to be. And you end up with an X-intercept, one and only one X-intercept of a possible 3 X-intercepts that is in order 1. Now, an order 1 means that we have no double roots, so no bounciness and no points of inflection, so no squiggleness on the x-axis. So the next thing I'm going to do is I'm going to take the original question and I'm going to find the y-intercept. I'm doing it there, knowing perfectly well that I have amazing technology that sometimes works, that will let me drag my work around. And a reminder, please label what you're doing, otherwise I will get lost and you will lose marks because you don't know how to label things, so you won't be able to state therefore statements or the equivalent of therefore statements. So 64 times 0 cubed is 0. 0 minus 27 is negative 27. And there's no orders about y-intercepts. There's no roots about y-intercepts. That stuff only goes with x-intercepts. So as I've said before, the only thing you need a ruler for is the x and y axis. And really, because I know what's coming in the units to follow, you should label your x and y axis. I'm going to label my one and only x-intercept. And I'm going to label my one and only, always one and only, y-intercept. Now, this is a degree 3, and it's a positive degree 3. So you should remember what a positive degree 3 looks like. And you can use all these hints to make this picture. So I can do pretty much anything I want to as long as this is N-shaped and goes through those dots. Now technically this is not the picture. I have to give you full marks because it has all the criteria of the picture. What this picture actually is of, in case you care, from grade 11, it is a squiggle. It is the x cubed. Let's try that again. But it doesn't squiggle through the x-axis, which means there's no points of inflection, because this criteria is only about the x-axis. Now, I'm going to put it back. Apparently, it's not cooperating. I'm going to put it back to this one. Oh, I cannot bump into the x-axis and make extra x-intercepts. I have to keep it below and do my N shape through those two dots only. And there we have a perfectly acceptable picture. Raptors down by 2. All right, so next question. You're looking at this and you're thinking, holy smokes, I have to do that f at x business. This is in standard form. Standard form is the enemy. No, not so much. This is my opportunity to remind you about Wayne Gretzky questions. Degree 3. So I'm going to take this and I'm going to slice it here. If I factor the front common factoring and the back common factoring and my brackets end up the same, which they will, I have a Wayne Gretzky question and I can avoid all of this stuff. A reminder, you do not have to do long division and synthetic division. It is your choice. So I can take an x squared out of those and leave x plus 2. Ignore the front. I can take a negative 9. 9's not good enough. Negative 9 out of that. Negative 9 out of negative 18 is, there it is. Oh my goodness. That makes it a Wayne Gretzky question. It means that I can haul my x plus 2 forward, and in a bracket behind, x squared minus 9. This is still a degree 3 because I've got x squared here and x here, which makes x to the 3. I can continue to factor because that back bracket is a difference of squares. So now I can go on and I can find the X intercepts. Can you tell I just looked at my TV? I'm telling you I'm finding the X intercepts. I'm telling you what I'm doing to find the X intercepts, then I'm doing it. Now, I always like to put in the green business. Don't feel obligated, but make sure you get it right without making any careless mistakes, which can happen even doing the green business. So I got -2, -3, 3. All of them are order 1. That means we have no double roots whatsoever and no points of inflection. So, I'm going to take a break because I got to watch the end of this game. Whew, okay, Raptors win. I'm now waiting for Stanley Cup playoffs. It's like a perfect night. I played hockey for the first time in 6 months today after COVID, and I paddleboarded, and now I'm sitting here talking to myself in math. Okay, so I don't even remember where I left off. We factored Wayne Gretzky style. Found the X intercepts. All of them happened only once. No repetitive brackets. That means they're order 1. And that also means there's no double roots and no points of inflection. At any point, so like now, at any point, you can start to draw your graph or sketch. And as I said in the previous question, please get used to labeling your X and Y axis. So right now, I can put on my -3 X intercept, my +3 X intercept, which I try reasonably to make an equal distance apart. And then I've got one at -2. Notice my scale is terrible. I'm not even putting in an effort, but my -2 is inside the -3, so numerically correct. Did I leave myself enough room? So I did degree of 3. I'm going to have to pull this down to find my Y-intercept. I'm going to put 0 in for all the X's in the original, which means I'm not multiplying, I'm doing bed mass. Don't forget to tell me what you're finding, tell me what you're doing, do it. 0 cubed is 0. Plus 2 times 0 squared is 0. Minus 9 times 0 is 0. Minus 18. 0 plus 0 minus 0 minus 18. Because this is in standard form, you are not multiplying these together, and I am showing way too much work. That's the Y-intercept, which I will plant here for fun. So, no bouncing, no squiggling through the x-axis. If I double check, this is a positive degree 3. That means I should kind of remember that it looks like that. So let's see if I can make it work for these points. Remember that if you choose to go up through this point, You don't know how high it's going to go. And you don't know how low it's going to go here. Maybe it's just going to go to there. You have no knowledge of that. And then the only thing I can do is go up through there with nothing fancy happening on the x-axis. And there is a perfectly acceptable picture. I will come back to that to do end behavior in a minute. Last question for graphing. Called E, but not really E. And this isn't really a Wayne Gretzky question. I'm not lying to you, but I guess I mislabeled it verbally. This question is not a Wayne Gretzky question. It's just in factored form, so you're supposed to be happy because you can start up. So with this question, the first thing I would do is look at it and try to figure out the degree, and then try to figure out its shape. So this is x to the 3 times a single x, doesn't matter about the coefficient, would be x to the 4, so we have a degree of 4. And it's all positive, so that means that I am most likely to end up with a W-ish picture. I know, super technical, W-ish. So I am going to tell you I'm going to find the x-intercept, tell you what I'm going to do to find the x-intercept, intercepts, and then do what I say I'm going to do. So depending on how much writing you want, 2 equals 0. Does not have an x attached, not worth writing down, but I like to anyhow to discuss the fact that that does not give you an answer. X plus 3 equals 0 will have an answer 3 times, so order 3. Keep that in mind. This will happen once. So we end up with x-intercepts of -3 and 4/3. This one is order 3. This one is order 1, which is why I tried to drill into you a little bit earlier when we weren't graphing that your degree matches the number of answers you're expecting. So with this question, there are no double roots, but there is a point of inflection at not -3 at x equals -3. Let's see what I can do for a picture. So -3, oops. Let's keep my coloring. -3 labeled. 4/3 labeled. Oh, this one's going to be a pain. I'm trying to find the Y-intercept so I know which way my point of inflection is going to squiggle. By the way, that is a very untechnical term, but it certainly is very descriptive of what's happening. All right, so 2. 0 times 3, sorry, 0 plus 3 is 3. 3 cubed is 27. 3 times 0 is 0, minus 4 is -4. So that's 54. That's -106 is the Y-intercept. And really, I went to way too much trouble for that. I am going to get a mark for finding -106 correctly, but I really, for the purposes of sketching, only need to know if it's above or below the x-axis. The -106 lets me label it accurately when I'm sketching inaccurately. So I have a choice. between squiggling that way, poor squiggle, and squiggling this way to make what I'm expecting the W shape. So that means I'm going with yellow as opposed to green. So let's see how good a job I can do. So squiggle, nothing fancy. So I don't like that. If you sketch in pencil, you can shift things around to make your picture better to your own personal eyes. So I'm going to use this as my bottom point because I actually don't have the information to tell me whether I go lower or whether I go through it as I've done here. But I like that picture better, so that's the one I'm keeping. And now I'm going to take a little break. Delete. I'm going to take a little break while I retrack, make sure I have enough room to talk about end behavior. So we're going to track back through all of the questions, and I'm pretty sure I've decided to start with this picture, which would have been the 1 to the 3rd picture that we looked at out of yesterday and today. And the reason I'm picking that is because I have moved to have some really clear space in this area. So give me a sec while I set a little bit of stuff up, and I'll be back. Okay. So the reason I wait to do this until the end is because I think end behavior is best done when you have a picture to look at, which is kind of the point of doing all this work anyhow. So you have 2 statements for end behavior. One of them looks like this, where you have a blank after your Y, and one of them looks like this, and you have a blank after your Y. Now, X's go sideways. So I like to write this on the up and down rather than all the way across the page, and the reason for that is negative infinity on the X's is way the heck down here on the left, so I keep this statement on the left of my page, and positive infinity on the X is way down here on the right, so I like to keep this on the right hand side of my page. So I don't usually flip these because it ends up messing with my brain. The Y's are on the up and down. So up here is the positive infinities, and down here is the negative infinities. Now, this is actually quite easy stuff if I explain it well, and if you give yourself enough patience to maybe get through a couple so that you can pick up like the pattern that's going on and maybe the language. So this says, as X goes to the left really big, Y is doing something. So as my picture is going to the left really big, this picture is going up. And as I said, up is positive infinity. So that's your answer for that blank. The alternative answer is it could have been going down, in which case you'd write negative infinity. Then you have to redo it, you have to say to yourself, as X gets really, really big to the right, what's happening to the picture? Well, the picture's heading down, and if the picture's heading down, that's into the very large negatives on the Y, so you'd say that. And that's it for end behavior. We're done. So the way you say this, which is why I needed the space, is, and I'll do it for this one only, as X approaches negative infinity, Y approaches, in this case, positive infinity. And you use the arrow rather than an equal sign because you can't equal infinity. You can only get closer and closer to it, so you can only approach it, which is why you use this symbol. So what I'm going to do is I'm going to flip back to the first picture and see if I can squeeze in end behavior. Now I'm going to keep it in blue because I think it stands out because I haven't used blue anywhere else. So I'm not even going to label it end behavior. I'm just going to say as x approaches negative infinity on the left, as x approaches positive infinity on the right, y does something. So what happens here? As we're heading to the left, this picture is going down, and down is heavy into the negatives on the y. As this picture goes to the right, this picture is going up. That's heavy into the positives on the y, and we're done to end behavior. That really means that every time you have a positive end shape, every single time you have a positive degree 3, you will have, I picked the wrong picture, didn't I? You will have the exact same end behavior. So let's just run through them all so we have all of them done. Here's a non-degree 3. This was a degree 2. It's actually a positive degree 2. Let's see if I can squeeze it in here. So as x approaches negative infinity, y will approach something. I can't do it left to right, so I'll do it first and second. So this is locked in. Your job is to fill the blank. So as x gets to the left into the negatives, what happens to the picture? So as we go left into the negatives, this is going up. Up is positive infinity. As this is going to the right, so positives on the x, this is still going up. It is possible to have the same direction for left and right. So that's one way to write it. Let's see if I have enough room to write it slightly different in the next one. Depends on how your brain works, which is why I'm giving you options. As x, oh, I always do that. As x approaches negative infinity, y approaches. As x approaches positive infinity, y approaches. You can write it right across your page rather than stacked. Totally up to you. As long as you use the right symbols, because math is communication. So you have to communicate this in a way that all other math people will be able to figure out what you're saying. So this says, as x gets heavy into the negatives, what happens to the picture? So as x gets heavy into the negatives, this picture is going down. Down is also heavy into the negatives. As this picture goes heavy into the positives on the x, what happens to the picture? It's heading down. You have a 50-50 chance there. Sorry, you have a 50-50 chance there. Hopefully you get it each time. So we're closing in on finishing up yesterday's. So I left enough room here, and then we'll start the 3 from today. So I'm going to go back to my left-right. Because my brain works quicker, not better, this way. So as this goes to the left, the picture is going up. As this goes to the right, the picture is still going up. Just as a little aside before we finish those last 3, that's why I had selected this picture. I'm not changing any of the work here, but I do remember one day I had a bunch of people away in one of my classes where I was explaining infinity, and one girl took my sideways figure 8 and did a sideways snowman, but didn't actually attach them to each other, and everybody who copied her note had infinity like this, which is not infinity. It's actually just i's. So make sure you do connect your infinity, and if you have a problem, draw yourself a figure 8, but turn your page sideways so that you have it like that. I think, if I'm not mistaken, the right side of the figure 8 is supposed to be littler than the left side. I know it's not equal, but I'm also not 100% sure, and my handwriting's bad enough as it is, so we won't go there. Let's see where I left off. Enough babbling by me. No wonder these things take so long. All right. This guy. Back to that positive degree 3. So I'm not saying you should memorize what all positive degree 3s are. I think that you should memorize how to correctly write down end behavior so that the rest of the math world understands what you're saying. So, left, down, right, up. Oh my gosh, there's another positive degree 3. Yeah, watch my magic. I think it would have been just as easy to write it down. Okay, so I'm not so magical. I thought I was so clever. Left, down, right, up. All right, so no cheating here. Last one. That box ends up in the worst spot. There's right. There's left. If you are having a rough day, remember that if you are sitting in my classroom, you can look up at the number line and remind yourself that the negatives are on the left of the x-axis and the positives are on the right of the x-axis. That should be in your brain, but sometimes your brain just doesn't work. If you're not in my classroom, I don't know, Google it. So, left, this picture is going up. Right, this picture is going up. And I just noticed two things. A little extra thing there. And let's get rid of that. So that is finally everything on this list except whether the function is odd, even, or neither, which is something that we will cover later on. It's actually simple once you get it. It's sort of like riding a bike, assuming you're okay with riding a bike. Anyhow, again, if you had taken that break after the first set before those last three and before end behavior, you could have been struggling through some of these, and now you can continue to struggle through some of these. Finally, the suggested questions match the suggested intended questions. So that is that. I'll be back at you with something else later.